Yes, everyone's back.
Yes.
Yes.
Okay. So we've done under the discrete distribution, we have done discrete uniform and binomial. Now we are getting into a more practical approach in life. That is, in real life, we have scenarios which are continuous distribution. Now, in that continuous distribution, first thing we are going to deal with uniform. So what is continuous? Continuous compared to the discrete, the continuous is the one where the number of possible outcomes are infinite, right? For example, the first one that we are going to deal with, continuous uniform distribution. Here on the screen, what you see is, let's say, if an employee has to reach to his workspace, uh, the average time that the employee has to reach is around 7 p.m. But the employee ends up at times being early, at times being late. Now, this is the range of his distribution. The earliest he has been is around 5 p.m. and the latest he has been is around 10 p.m. So between 5 and 10 p.m., what are the number of possibilities that he must have reached the office? There can be n number of possibilities, right? Because the time is continuous, isn't it? Am I clear, everyone? There must be n number of possibilities, right? Why? Because he must have reached at times 5 p.m. and 5 minutes and 25 seconds and some microseconds. So the time duration between this two period, can I say, is limited or unlimited? Everyone?
Unlimited.
Unlimited, right? So there are unlimited possibilities between this period. So what should be the scenario here? This is a continuous distribution, but when I say continuous uniform distribution, I assume that all the possible outcomes here will have equal probability. That's the meaning of uniform, right? So you pick out any number between 5 and 10 p.m. I will say the probability of all the numbers between 5 and 10 is same. First of all, how many numbers do I have between 5 and 10? I don't know. Let's assume that you have n numbers. How many numbers you have? N numbers, correct? So the possibility of all the outcome is same, correct? So what is the possibility of each outcome? Can I say the possibility of each outcome is 1 over n? Am I clear? Why? Because the number of possible outcomes are infinite and the possibility of all outcome is same. That's why it's called continuous uniform distribution. And under continuous uniform distribution, the probability is the same for all outcomes. Am I clear? Yes, no?
Yes.
Now, do you recollect something of doing probability function and cumulative distribution function? Where we had written on the screen that we'll have to come back on this page. Probability function and cumulative function for a discrete random variable is what we have done. Now we are going to do that for a continuous random variable, the right hand side part. Are you with me? So I've put it back in the table here as well. So what is the probability function and the cumulative? Probability is a specific value and cumulative is a value till that point, less than equal to. Everyone with me? And how is it denoted? Under continuous random variable, it is denoted as smaller f of x, which is called probability density function, or a larger f of x, which is called cumulative distribution function. Now, how are you going to remember? Whenever the sign is equal to, it is probability function, and whenever the sign is less than equal to, it is cumulative function. Am I clear, everyone? Yes. Cumulative and probability.
Yes.
Cumulative means cumulative frequency. Probability, you can say absolute frequency. Now, let me take a step further. Let me connect this in terms of getting the probability answers. For example, let us say the smaller number, the lower value on the distribution. For example, here I said that it is the lowest is 5 p.m. and the highest is 10 p.m., right? So that 5 and 10 p.m. now we'll give some alphabet A and B. A is the lower bound and B is the upper bound. So here, if I say A is the lower bound and B is the upper bound, correct? Can someone tell me what is the distance between A and B? How will I write the distance between A and B? Can I write it as B minus A? Isn't it, everyone? B minus A, everyone?
Yes. Yes.
So the distance between B and A and B, let's say A is 0.0, B is 0.20. So I can say the distance between A and B is 20. How will I get 20? B minus A, correct? And how will I get the probability, guys? We just discussed the probability for continuous uniform distribution. All the outcomes will have same probability. So what should be the probability? If the distance between A and B is B minus A, what should be the probability? Can you tell me?
B minus A by N.
Sorry?
A by N.
Any number will have the same probability, that is 1 over the distance. So can I say 1 over the distance, 1 over B minus A will be the probability for any number between A and B. Am I correct? What is the distance between B and A? That is B minus A. And all the distance will have same probability. Let's say the distance is 100. So all the numbers will have the probability of 1 over 100. Correct, everyone? So if you're looking for a value, that is, let's assume that value is X. And if that X is between A and B, then the probability will be, if the X is greater than A, let's say here the X that I'm looking for, if that X is greater than A or less than B, then the probability will always be 1 over B minus A. Am I clear? Correct?
Yes.
But now you have to tell me, what if the X that you are looking for is less than A? X is below A. What is the probability of it? For example, here, if I say, what is the probability of I coming, or the employee coming at 4 p.m.? What would be the probability? Think.
1 minus 1 upon N.
See, the probability is only for the number between 5 and 10, right? Below 5 or above 10, is there a possibility here? Well, no.
No.
So the probability for X, if it is below A or if it is above B, it will be always 0.
No.
Are you with me? Outside the range, it will be 0. Am I clear?
Yes.
So this is for the specific value. But now interesting thing comes for the cumulative. For the cumulative, let's say if I take the lower value as A and the larger value as B, the lower bound as A and the upper bound as B. And if you're looking for X, let's say X is somewhere between here. This is X. So if I now want to find the distance between X and A, what is the probability between X and A? How much is the area between X and A? Can you tell me?
X minus A.
Correct. So it will be X minus A, right? Out of the total distance, what is the total distance?
B minus A.
B minus A.
B minus A. So if your X is somewhere between A and B, if your X is somewhere between A and B, that means I can say greater than A or less than B. In that case, my probability will be X minus A over B minus A. Am I correct? It is basically, you know what? The required distance divided by the total distance. If you just want to write it for your reference, I can say this is nothing but required divided by the total. Isn't it? Everyone with me?
Yes.
Now interesting thing comes, cumulative. Okay, cumulative means till that point. So guys, tell me, if your X is below A, if your X is below A, what is your probability?
0.
Very good. Your probability will be
Probably.
0 for this, right? For this case, it will be 0, isn't it? Isn't it? So if your x is less than a, I will say the cumulative probability is 0. But now you have to be careful. If your x is greater than b, x is greater than or equal to b, then what will be the probability here in this case?
1. 1.
Okay, I got one of the answer as 1. Is he correct? Why is that 1? Do you remember something of this we did today?
Yes.
Where when I told you rolling of a dice, the probability for getting 10, exactly 10 is 0, but till 10, let me show you. Here, do you remember the cumulative for 10? Even if the probability for 10 is 0, the cumulative for any number above the largest number was 6. The cumulative for any number beyond that is going to be 1, 1, 1, 1, right? You recollect this, guys? Everyone?
Yes.
So now these are the formulas. The probability function is small f of x. For any number between b and a is 1 over the distance, which is b minus a. Outside the range, it is 0. But the cumulative, see the cumulative, the graph, do you see? It keeps on increasing. You remember the cumulative for getting first, getting second on the dice, it keeps on increasing. We had written increasing, right? But after the largest number, it is constant, it is 1. Correct? Should I recollect you that, everyone? See here, the cumulative was increasing 1 by 6, 2 by 6, 3 by 6, and after the largest number 6, it's constant 1. Now imagine the same thing in the diagram that we are doing here. The cumulative keeps on increasing. That's why you see the slope going upwards, the curve going upwards, and then it's constant. Clear? Now how to remember the formula? Under cumulative, just remember required divided by the total. That's what you need to remember under cumulative. Required divided by the total. Okay. Now, trust me. Now, when I'll do the examples, you will not even require all these formulas. You want to see that? See this. Can someone read this question for me? Go ahead, anyone. Yes, Deepthi, go ahead.
If variable x, which is continuous uniformly distributed,
So they have mentioned it is continuously uniform distributed. Okay. Yes.
has lower value of 0
And
higher value of 35.
so lower value, that means A is 0 and B is 35, correct? Fine.
Yes.
What is the first question? The probability that x is greater than 21. Now see this. What is the lower value that you got, guys? 0. And the larger value that you have, the upper value is 35. And you are being asked for the probability that x is
Greater than
21. Can I say 21 is between 35 and 0 somewhere? And the area that I'm looking for is this, isn't it? Yes or no?
Yes.
Yes.
So without formula, you can tell me what is this distance? Can I say this distance is between 35 and 21 out of the total distance, which is 35 minus 0. Am I correct? Got it?
Yes.
Yes.
So 35 minus 21 divide by 35, you'll get an answer of 0.4. So I can say there is 40% of chance that the value is greater than 21. Am I correct? Right? You don't even require the formula. Should we move to the second one?
Yes.
What is the second one? What is the probability that x is between 7 and 14? What is the lowest number? 0. Highest number is 35. And now you want the distance between the probability between 7 and 14. Can I say 7 and 14 is somewhere between? So this is the area that I'm looking for. Now you don't have to remember the formula x minus a and all that thing. You don't have to do it twice. You just simply need to apply the logic, and the logic here is what is the required distance, guys? I can say 14 minus 10 divided by the total distance, that is 35 minus 0. So 14 minus 7 is 7 divided by 35. I'll have this probability as 0.2. I don't want you all to go through a longer process of first calculating the distance between 0 to 7 and then 14 to 35 and so on. You can simply do the diagram and apply the logic there. Everyone with me?
Yes.
Easy. Clear. Any questions, anyone? What is the technique? Just plot on the diagram the lower and the upper bound, and then look at the question what they have asked. Had they asked less than 21, I would have shaded the below 21. They asked more than 21, so I shaded that. So the required divided by the total. It's very easy. Okay.
Yes, sir.
Clear. Now, the way we calculated mean and standard deviation under binomial, we are also going to calculate here mean and standard deviation under the continuous uniform distribution. Everyone with me? Now, under continuous uniform distribution, the mean is nothing but this. You know what is generally the formula of mean? You take all the numbers and divide it by the number of years or the number of variables, right? But under continuous, guys, how many numbers you have? You have infinite numbers, right?
Yes.
So the simplest way of calculating mean under continuous, which you will have to remember, is just take the average of the largest and the smallest number. Simple average. Why are we doing this way, guys? Why am I going to take b plus a divided by 2? Why am I going to do that, guys? Because
Continuous
here
distribution and
Infinite.
there are infinite possibilities. Am I correct? So in that case, the mean of the distribution will be simply b plus a divided by 2. Everyone, if you all want, you all can even write it down. Guys, the mean of the distribution should be b plus a divided by 2. I think it's not visible here. Just a moment. Okay. Now, when I calculate mean and standard deviation, basically we want to calculate standard deviation, but unfortunately we first have to calculate the variance and then we convert it into standard deviation. So here the mean is b plus a by 2. How do you calculate the variance? Well, we calculate the variance as x minus x bar the whole square, right? In this case of continuous uniform distribution, the distance is what? B minus a. So what we are going to do is b minus a the whole square. This is what we are going to do. Why? Because there are infinite possibilities. And what we are going to do is that we are going to divide it by, what do we divide it generally by? N, right? But here, unfortunately, we do not have n. So here, in case of variance, there is a unique number that we divide by, and that number is 12. Now, why 12? I will first say why 12. Now, 12 is a very unique number. If you compound anything 12 times, the answer is closest to continuous distribution or continuous compounding. I'll repeat. For example, if you do square of 10%, if you do 10% compound twice, so it will be 0.1 into 0.1, correct? Similarly, if you do square root twice, but instead of doing square root or square twice, if you do it 12 times, you get an answer equal to the continuous answer. So by doing 12 times at least, your answer is closest to continuous compounding. Okay. So if in the calculator, if you just press square root of anything 12 times, the answer is close to log. ln, log natural. And if you do square of anything 12 times, the answer is closest to exponential. That is continuous compounding. And that's the reason why there is this number that you have to remember. By the way, there is no justification of this number in the CFA Institute book or in any other book. The reason that I'm telling you, because 12 is a unique number. There are lots and lots of theory of this 12 number in the in the Google also, if you see. So 12 is a number which will give you answer closest to the continuous number. And therefore, why are we doing this? Because in continuous distribution, your number of possibilities are infinite. They are not countable. So for mean, we use a simplified version, is that we take a simple average, but for variance, we divide it by 12 instead of, n, we divide it by 12. Remember this, okay? Now, this may sound complicated, but when I'll do that in the question, it will be relatively easier. So let's take a question and calculate the mean and standard deviation. A fund manager has a mandate to invest in growth stocks with a minimum return on equity of 20%. By the way, what is return on equity? ROE. The formula for ROE. Return on equity is net income over equity into 100. Correct? Sorry. The formula for ROE is net income over equity into 100. Clear, everyone? So what is the mandate here, guys? What is the mandate? That the fund manager will pick up stocks whose ROE is
20%.
Greater than 20%.
20%.
Because they said minimum I need 20. So it should be more than 20, right? Then you pick them up, correct? For one of the stocks which currently forms a part of the portfolio, he forecasts next net income for the next year in the range of 15 to 28 million. Guys, what is this 15 to 28? Range of 15 to 28. Can I say this is the lower bound
B minus A.
and the upper bound? Am I clear, everyone? So 15 to 28 will be the lower and the upper bound, everyone. The company shareholder has 100 million equity. Guys, if the equity is $100 million, how much should be the ROE? Can I say the ROE should be 100 million into 20% minimum? Which is how much? It should be 20 million, isn't it? Minimum. Correct, everyone? Yes or no?
Yes.
And
Yes.
can I say 20 million is between the lowest and the highest number? Right? If it is greater than 20, will it become a part of portfolio or not?
Yes.
But if it is less than 20, it will not be a part of portfolio. Am I correct?
Yes.
Now, what makes me say that this is a continuous uniform distribution? Until now, they have not said anything like that. But now they have put up something unique. Assume that the outcomes of net income are equally likely. First of all, how many outcomes can be there between 15 and 20? There can be infinite outcome. It can be 15.11111, 15.000, and so on. But one thing that they have told me that all the outcomes have equal probability. That confirms me that this is dash 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 continuous uniform distribution. Am I clear, everyone? Now, what is that they have asked? They have asked first question, what is the probability that the stock will not remain the part of the portfolio? Will not remain when the value will be greater than 20 or less than 20?
Less than 20.
Less than
20. So can I say I'm looking for this area? Am I correct? Less than 20. So without the formula, you can tell me how do we calculate the probability here, guys? The distance is 20 minus 15 divided by
13.
28 minus 15, correct? And that will give you the probability. So 20 minus 15, that is 5 divided by 13. Your answer is going to be 0.3846. Everyone getting this answer?
Yes.
So can I say there is 38% chance approximately that the stock that we are looking for will not be the part of portfolio. And if I do -1, I can also say that there is 62% chance that this stock will be the part of portfolio. Am I clear?
Yes.
Everyone with me?
Yes.
Now, how do I calculate mean for all the numbers? Simple. I will just do the simple average here. Because in the second part, they have asked what is the mean and standard deviation of the ROE. The ROE range I know is 28 and 15. So 28 plus 15 divided by 2, that will be the mean. And for variance, I'll do 28 minus 15, the whole square. Divide by that, you can say that lucky number. What is that lucky number, guys?
12.
12 is what you have to remember, because you have infinite outcomes. And then whatever the answer you get, that will be the variance. You do the square root, you'll get standard deviation. Let me know, guys. 28 plus 15 divided by 2. Your mean of earnings will be 21.5. And your variance will be 28 minus 15 divided by 12. And whatever the answer you get, you will do the square root of it. So I think you'll get 3.75, right?
Yes.
So now how do I present this to the client? I will say that, sir, based on the available information, the expected ROE of the company is $21.5 million with a standard deviation of 3.75. Everyone with me? Correct?
Yes.
Clear. Any doubts, anyone? I am sure you all are recognizing the fact that the diagram helps a lot. Yes. Any doubts, anyone, till this point? No doubts? Okay. So tell me, what types of distribution have you done till now? Discrete
Random
and
standard.
continuous. Under the discrete uniform, correct?
Yes.
And same way, like discrete uniform, you have continuous uniform, where the probabilities of all the outcome are same.
Same.
Then under discrete, you did binomial, correct?
Yes.
Where there are only two possibilities. And now we will, under the continuous one, we will be doing something that we have already done in the past, but we'll take one notch above. And that is the most important type of distribution, which is normal distribution. Everyone, normal distribution. Most of the things that you see here under the normal distribution is what we have covered already. It was invented by the French mathematician called Abraham Mover in 1733, right? When you were probably 2 or 3 years old, correct? So in that century, I mean, in your past birth, probably. So that is what normal distribution is. And but the unique thing about normal distribution are its properties. Now, where it is used, you can just probably go through it. It is used in various fields of finance. It is very much used by investment professionals, exclusively in the stock markets. Mostly in finance, wherever you have mean and standard deviation as your parameters, we use normal distribution. Normal distribution is the most famous distribution. What are the properties of normal distribution? Guys, come on, you all have to tell me. Only two parameters, right? The mean and the standard deviation. Correct? Equally distributed. And do you remember your doubt, Deepthi, that all the normal distributions are symmetrical, but not all symmetrical distributions?
Not all symmetrical. Yes.
Right? That is important. Then
Yes.
the skewness is 0. The mean, median, and mode are same. The kurtosis is 3. Everyone. And see, one more thing. As and when you move away from the mean, the tails get smaller and smaller, right? So the probability of outcome further and above the mean gets smaller and smaller. As and when you go away from the center, the probability goes smaller and smaller. However, still there is infinite possibilities. And therefore, if you see at the bottom, there is infinity. Clear? Everyone.
Yes.
Now there's one more property here, that the linear combination of normally distributed random variable is also normally distributed. For example, if let's say one of the stock that you're looking for, if it is normally distributed, then I can say the portfolio of the stock is also normally distributed. That is the assumption. I'll repeat. If the stock is normally distributed, then I can say the portfolio of stocks is also
Normally
Normally
distributed.
distributed. Correct, everyone. Everyone, any doubts? Anyone till this point, guys? We have already covered this in the past, right? Now, this is a normal distribution. Now, whenever I will do normal distribution, guys, what will be my mean? That will depend on what the sample or what the data is. Correct? So mean can be any number. For example, the calculation that we did here, what was the mean here, guys? 21.5, and then the standard deviation was 3.75, right? In binomial, when we calculated the mean, our mean was 9 and the standard deviation was 2. I mean, it was 8.7 and 1.91, right? So depending on the sample that you have, you will have different types of mean and standard deviation. Am I correct? Now, the objective of normal distribution is to find the probabilities of any question that they ask. And in order to get that, I will need to have a common normal distribution, a standard normal distribution. Only then I can find the probabilities. And where do I find the probabilities, guys? I've added here the distribution table. The distribution table is the one where you get the probabilities. The probabilities for all the values that you're looking for. All the values that you are looking for. However, what are these values? These are distances from the mean. So if the distance from the mean is this, here you see x or z, x or z on the left vertical. What is this? This is the distance from the mean. Am I correct? So if the mean is something, how much away is the distance? How much away is the standard deviation? That standard deviation is right on the vertical line of x or z. And then based on that, you have the probabilities. Now, don't worry about how to read it. I will explain you. But the table that you saw is meant for one common type of distribution or one common type of mean, which is called standard normal distribution. And under standard normal distribution, we assume that the mean is 0. That the mean is, guys, what? What is the mean?
0.
Mean is 0. So what is the probability of a value? What is the probability of a value which I can say which is away from the mean? So if how many standard deviation away from the mean, if I want to find, how will I find that? I will have to go to the standard normal distribution table. But before that, guys, an interesting thing is that we need to understand the difference between normal distribution and standard normal distribution. Well, as I said, under normal distribution, what is the possibility that your mean and standard deviation may or may not be 0? Correct? The mean may not be 0 always. But under standard normal distribution, guys, our assumption is that the mean is always 0.
0.
So if I want to find the distance from the mean, let's say if I find the distance of 1, so 1 can be -1 and +1. Am I correct? Correct? Yes or no?
Yes.
So if you want to find what is the probability of this value, how will you find that? This distance. You will go to the distribution table, guys, and get the probability of it. Get the probability of how many deviation? 1. So guys, let's go to the distribution table and find the probability for 1. Now, in this basis, we'll get some probability. We'll see how to calculate that. So here you have the distance 1, and for that we'll calculate some probability. Okay, we'll see that probability. So that will give me the probability of distance of 1 from the mean. Am I correct? In the same manner, if I want to find the distance for 2 from the mean, so where is 2? I will say 2 is beyond 1. So -2 and +2. Am I correct? -2 and +2, sorry. So when I do -2 and +2, I'm looking for the probability for this distance, right?
Yes.
Certainly, your logic must be on place now, and you will fast apply it. if the probability of the distance for 1 is something, the probability for distance of 2 will be more than that, right? It is broader. And if I say for the standard deviation about 2, let's say the standard deviation of 3, then its probability will be more than 2.
Yes.
So what we are going to do is that we are going to find the probabilities of some distance from the mean. Probability of distance from the mean. Am I clear? That is called applying the standard normal distribution. Now what do we need to find? The question will tell us. But standard normal distribution is unique normal distribution where the mean is
0.
0 and the standard deviation can be 1, 2, 3 and so on. Everyone clear, right? Okay, now comes a very important thing, and for that we have to discuss what is z value. But in order to describe what is z value here and do everything else, I will unfortunately have to take you directly to the example and then show it. Okay, now bear with me for a while. I will first explain the example and then connect it with what we are going to do, what is z value and all. So what is the information given here? That the mean and the standard deviation of the returns are given. Guys, can you tell me what is the mean here? Mean?
4.8.
4.8 and the standard deviation is 3.6, right? Now I will plot that into the diagram. Right in the center, I have mean and the mean is 4.8, correct? And the standard deviation is 3.6. Now, what is the question that they have asked me? First, that the returns will be
Negative.
negative. Now, guys, if the mean is 4.8, negative means below 0. Can I say 0 on the left hand side? Yes, everyone?
Yes.
And what is that I'm looking for? I'm looking for the probability below 0, right? Negative is below 0. Am I correct?
Yes.
So I'm looking for the probability of this part, right? Now, the problem is that when I go to the standard normal distribution, the mean there is 0 and the standard deviation is something else, right? But my mean is 4.8. So what should I do? Guys, I should convert my normal distribution into the
Standard normal distribution.
standard normal distribution. And guys, under standard normal distribution, what happens? The mean is
0.
0 and we are looking for some value which we don't know what is that value, and we are looking for the probability below that value. Am I clear? How do I know that value? That value is what we calculate through the function, through a formula that is called z-score. And what is z-score or z-score? It is something that will convert your dash into dash. What? It will convert your normal distribution into standard normal distribution. Am I clear, everyone? How do I do that? The formula for z-score is this: x minus mu over standard deviation. What is x? X is the value that you're looking for, the target, minus the mean divided by the standard deviation. It will tell you the distance, how much is it away from the mean, proportion to the standard deviation. So the numerator that you see is actually the distance that you're looking for. So I'll write here, the numerator is nothing but the distance that you're looking for in proportion to the standard deviation. That is what z-score. Now what I called the z-score, I call it as a converter, not your institute. I call, for my reference, I call z as a converter or translator. Why? Because what z does is that it converts normal distribution to standard normal distribution. Everyone, Why would I do that? Guys, I'm doing this so that I can find the respective probabilities. Am I correct?
Yes.
Yes or no, everyone? So what is the use of Z? What will it give me? Z is called as Z score or Z score or Z statistic. What does Z do, guys? Z, it is used to standardize an observation from a given normal distribution. So you are converting a normal distribution to the standard normal distribution. It denotes you, or it gives you number of standard deviation away from the population mean. Number of standard deviation away from the population mean. That is what it will give you. So now see, when I go to example 9, how will I calculate the z-score? What was the formula, guys? The z-score was
X minus mean by standard deviation.
x minus mean. What is the x that you are looking for here, guys? If I say x minus mean by standard deviation, the value that you are looking for returns below zero. Below zero you are looking, right? So you are looking for the specific value here is 0. So I will write 0 minus the mean divided by the standard deviation. So you will do 0 minus 4.8 divided by 3.6. And your answer will be, everyone, let me know your answers.
Minus 1.6.
Minus 1.33. Am I correct?
Yes.
2 decimal, only till 2 decimal. Minus 1.33. Now that is the distance from 0. So the distance that you are looking here, the z-score that you got is minus 1.33. Everyone with me? Did you realize what did I do? My mean and standard deviation was something else, right? I converted that into z-score. So as per the z-score, what is the distance from 0? Minus 1.33. Clear? Why am I doing that? Because the probabilities are given for standard normal distribution. You cannot have probabilities for all the numbers in the world, all the mean. You have to have a standard probability table. Everyone. So what distance am I looking for?
1.33.
1.33 negative, right?
Yes.
So here we go to the distribution table, and here you have two values. One is the positive value and the second table has a negative value. We are going to the negative value of 1.33. Now, how do I read or how do I find 1.33? See this. In the vertical column, where do you see 1.3? 1.3 here. 1.3 exactly here. Am I correct? Negative 1.3. Everyone? Do you see that negative 1.3? Everyone? And I need 1.33. So on the horizontal line, see 0.03. Why 0.03? Because that together makes 1.33. This is the way you have to read. 1.3 and 0.03. That becomes 1.33. Am I correct? So what is that number, guys? That number is 0.0918. Are you getting it, everyone? Yes, no?
Yes.
From 1.33. So I take 1.3 and 0.03. Now that probability is 0.0918. Now 0.0918 is the probability of getting till 1.33. First of all, I'll write the probability 0.0918. So how much is this probability, guys? I will write it down here. This is 0.0918. So I can say 0.0918. This is the probability of the value that I was looking for. And what was the value I was looking for, guys? I was looking for the probability for my returns being less than 0, isn't it? Returns being negative. Am I correct? And what is the probability, guys? It is 0.0918, which is nothing but I can say 9.18%. Am I correct? Yes or no?
Yes.
So now how will you explain this to the client? You will say the client that the probability of getting negative return is 9.18%.
9.1.
And how did I get? I converted my mean and standard deviation into the standard normal mean and standard deviation. because based on that I get the probability, and I use the concept of z-score. So z-score is nothing, it's a converter. It converts your normal distribution into standard normal distribution. Am I correct?
Yes, sir.
So if the probability, now apply the logic, if the probability of getting below 0 is 9.18, so can you now simply tell me what will be the probability of returns being positive?
0.9082.
1 minus 0.0918. Am I correct? Which is going to be
9.9082.
9.9082, or I can write 90.82%. Am I clear? Well, in this case, I can say that I was looking for the distance above 0. So I was looking for, this is 0, this is 4.8, and I was looking for probability above this value. Am I clear? Yes. Right? Yes or no, everyone? Why?
Yes.
Because I knew that this probability of 0 till 0 was 0.0918. The total is always 1. So the remaining part, this entire part is how much? It is 0.9082. Everyone clear? Now, one thing that I need to highlight, that when you go to the distribution table, you get the probability. But I have written something here. Can someone read it for me? While looking out for probability from the distribution table based on z-score, remember that it always gives you, what does it always give you? What have I written? Cumulative probability from the extreme left side. What do I mean by that? That whenever you are looking for probability, it will always give you, let's say in the middle you have 0. Your x can be positive or negative. What do you want to assume? The value that you're looking for can be above or below the mean. Well, if you're looking for something below the mean, let's say this is minus x. What is the probability that you're getting? You're getting the probability of the tail, the left tail. Why do I say left tail? Because the probability is always from the extreme left hand side. Are you getting me? In the distribution table, the value that you are getting is always for the cumulative value from extreme left hand side. From, you know, the cumulative frequency starts from the lowest or the highest number. You take the lowest number and keep on adding it, right? Correct,
Yes.
correct. Now, one more thing. What if your x is above 0? For example, let's your x is positive number. Still, if you go on finding the probability, you will get the probability from which point till which point? Can someone tell me from which point till which point? If you're looking for probability of x, which is positive, from the table, you will get the probability from always and always from the extreme left hand side till this. It's a cumulative value that you will get. Are you with me, everyone? Clear? Why? Guys, please read this. Because the probability that you will get is always from minus infinity to the value that you are looking for. That x is nothing but your target value. Are you with me? Why? See this. See this. In the example that we did, we got the probability from the extreme left hand side till 0. So if they asked us only for negative return, you take that. If they ask you for positive returns, you take the other side. Because from the table, you'll get only 9.8, 9.18, which is the bottom. Got my point? Yes or no?
Yes.
So see the next question. What is the probability that the return will fall below the risk-free rate of 1.2? First of all, how do I put this into the diagram? See this. What is the mean that we had? 4.8. And can I say 1.2 is below 4.8 or above 4.8?
Below.
Below. And what is the probability we are looking for? We are looking for the probability of value below this point, right? Below risk-free. Am I correct?
Yes.
But I can't find the probability for this because this is a normal distribution. So I need to convert this into standard normal distribution using z-score. And z-score will give me a value for some point below the mean, for some distance below the mean. I don't know what that value is. I need to first find that z-score. How will I find the z-score, guys? Tell me.
X minus mean by standard deviation.
The target here is 1.2 minus the mean divided by the standard deviation. Guys, let me know the answer. 1.2 minus 4.8 divided by the standard deviation. You will get the answer as -1. Am I correct?
Yes.
So -1 is what you're looking for. -1 is the score. So we go to the distribution table and find the value for -1. Once we find the value, we'll get the value from negative infinity till -1. We'll get from this point, the last point, from this negative infinity till -1, correct? And that's what we are looking for. Am I correct? So go to the distribution table, go to the negative -1. What is the probability for -1 and 0, 0? Can you see that here? What do you see? -1.00. What is the probability? 0.1587. That's what you observe here, guys. So what is the probability of this area? It is 0.1587. Or I can say the probability of getting returns below risk-free. Now below risk-free is nothing but risk-free is how much? 1.2. The probability is 15.87%. Am I correct? Yes.
Yes.
Everyone. Now everyone knows why do we use z-score? Tell me, why do we use z-score?
To convert normal distribution into standard distribution.
Very good. To convert the normal distribution data into standard normal distribution data so that we get the probability from the distribution table. And those probability are cumulative probability till that point. Correct. Now, at times you have to do the adjustment like you did in the second part. At times you can directly get the values like the first and the third part. Now, the fourth part is very interesting. Fourth part is very interesting. What will be the returns between 1 and 6? Okay. Now, guys, interesting thing. When they say between 1 and 6, tell me our mean is 4.8. Am I correct? 1 is below 4.8.
Yes.
And 6 is above 4.8. And we are looking for probability for this area. Correct? But when you go to the standard normal distribution, there is a problem. What is the problem? You don't get the value between, you get the value from infinity, right?
Yes.
So what I'm going to do is that when I will convert this into the standard normal distribution, I will first have to split this into two parts.
Infinity.
Very first, I will find the distance for values for 1. But which distance will I get?
Minus infinity to 1.
Yes, very good. I will get from minus infinity to 1, correct? Then I will find for distance for 6. For 6, how will I do? See this. 4.8 and 6. Guys, when I will get the distribution for 6, for the probability for that, I will get the area from, I will get the probability from minus infinity till 6, right?
Yes.
But I don't require minus infinity to 6. I require between 1 and 6,
1 to
right?
6.
Are you getting me? So if you carefully look here, guys, you will get the distance of 1, below 1 and below 6. And you need the middle part. So You need to guess something. We will see that what it is. But these are normal distributions, right? These are normal distributions. I need to convert them into standard normal distributions. Am I correct? So when I convert this into standard normal distribution, I will get some value twice. I will get the z-score twice. One will be above the mean and one will be below the mean. I will get this value and this value. Everyone with me? These are my standard normal distributions. So I will convert the normal distribution into standard normal distribution by applying the z-score. Am I correct? So how do I calculate z-score for the first one, guys? For this?
1 minus 4 by 8, 4.8 divided by 3.6.
So for the first one, the z-score will be 1 minus 4.8 divided by 3.6. And for the second will be 6 minus 4.8 divided by 3.6. Am I correct? Let me know the respective z-scores, guys.
Minus 1.33 and 0.33.
1 minus 4.8 divided by 3.6. So it is minus 1.06. The first one is minus 1.06. And the second one is 6 minus 4.8 divided by 3.6. It will be 0.33 plus. So this is minus 1.06 and this is 0.33. Got it? Everyone with me?
Yes.
So I will get here the probability for minus 1.06 but less than minus 1.06. Okay. And I will get a probability for 0.33. Clear? So let's go to the table, everyone. Minus 1.06. Help me with that. Minus 1 and 0.06. Minus 1 and 0.06. How much is the value that you see here? Minus 1 and 0.06. What is the value?
0.1446.
0.1446. That's the value, right? Here. 0.1446. And the second we had is positive 0.33. So I'll go to the positive 0.3 and 33. And what is the positive 0.33? It is 0.6293. See this 0.3 and 0.03. That is 0.33. That is 0.6293. Correct? So this part is 0.6293 and the other part is 0.1446. Everyone with me? So what is the probability, guys, that the value will be below 1.06 is 0.1446 and it will be below 0.33 is 0.6293. However, what are you looking for? See, guys, you have been given this probability and the total probability. But I am only looking for the distance between 1 and 6, isn't it? What should I do? Apply your logic here.
0.6293 minus.
I am looking for the probability for the value which is greater than 1 and less than 6, right? So if the total distance till 0.33 or till 6 is 60 to 93, out of that, the one which is below 1, that is 14.46. So if I exclude that, if I exclude 0.6293 from 0.6293, 0.1446, I will get the remaining part, isn't it? So see this, from this entire part, if I subtract the tail, the small tail, then I will get the remaining part that is from 1 till 6. Isn't that the case, guys?
Yes.
0.6293 minus 0.1446. So that answer is 0.4847. That would be my answer, guys. Very important. Clear, everyone? We use the unique way of doing it. See, the problem is that First, you have to convert the normal distribution into standard normal, right? The second problem is that from the standard normal distribution, you always get the probability from the extreme left, from minus infinity till the value. However, we may not always want that. We may want to twist it. Therefore, in that case, you will have to logically see what is asked and what do you get from that. You have to adjust. So I was getting from minus infinity to x. I subtracted the tail value. Then the remaining value is what I got. Everyone clear with this? Correct? Isn't it interesting, everyone? Now, in exams, you will be given the values of the table. All these distribution values, you will be ready-made given in the exam. Don't worry about that. Correct? Now, if you remember, anyone any doubt till this point? See, this one sum covers, this one example covers all the normal distribution possibilities that they can ask. I've covered everything in this. Correct? From normal distribution to standard normal distribution. Everyone cleared the concept. And trust me, you must have realized by now that the diagram is so important. Without diagram, without the normal distribution curve, if you don't draw that, you won't understand anything. Of course, after practice only you can make it perfect. I'm not expecting you to remember it now. Once you practice it, it will be much easier. But at least in the class right now, are you understanding the logic, everyone?
Yes, sir.
Yes.
Now, one thing I need to share, that at times what happens when you go in exam, here they had given you the distribution table for positive and negative values both, right? And because we say that the values are always from negative infinity till x, how do I come to know? See on the distribution table on the top, what have they written? They have written on the top for x when you are in the positive values, what have they written? For x greater than equal to 0. But if you see the probability, what have they written? Cumulative probabilities. Do you see that? Cumulative probabilities, guys. And whenever they say cumulative probabilities, guys, it means that they have given me the distance from
Minus,
come on,
minus
from,
infinity to a point.
yes, from negative infinity till x. So they've always given me distance from minus infinity till x when the x is positive. Okay, this is what they've given. Similarly, in the case of negative, if I go in the negative, again they have said cumulative probabilities. So cumulative probabilities is till that point. So how will I write the cumulative, guys? In this case also they've given me values from the negative, but now the negative infinity, the negative value will be on below the mean. So they've given me this distance. Got it? From minus infinity till minus x. Everyone, that's what we realize, right? However, they may in exam they may give you only the positive or only the negative values. For example, you are looking for 1.33 negative, right? How much was the value for 1.33 negative? You got 0.0918. Am I correct?
Yes.
Now, what if they don't give you, you wanted 1.33 positive and they don't give you the table of positive. They give you only the negative table. So what should be its answer? Normal distribution. Yes, 1 minus this. So what is 1 minus this? 1 minus 0.0918. It is 0.9082. So let's check out for 1.33 positive. So 1.3 and 0.03. So it is 0.9082. Do you see this?
Yes.
So what am I trying to make out here? I'm just trying to make out here, guys, that if they give you only the positive or the negative table, don't worry. If they give you positive or only negative table, you can just find the alternate by doing 1 minus that. Clear? If they give you both tables, nothing like that. But if they don't give you, don't worry. It's just the mirror image. If the probability for some number is something, the opposite number, the negative number is just 1 minus that. Clear, everyone?
Yes. So for the previous example,
Which one?
where it was minus, just, yeah, this one.
-1.
Uh,
Yes, which one?
between 1 to 6.
Between 1 to 6, right?
Yeah. So when we found for 0.33, so we
Right.
can do, we look for the positive one.
Yeah, but even if you look for the negative, you can just simply do the opposite.
Opposite. Okay.
So if I go for distribution table and if I go for negative 0.33, see this is 0.33. How much is it? 0.3707, right?
Yes.
Correct? So just do 1 minus 0.3707, you'll get the answer as 0.6293. One minus 0.3707, you'll get 0.6293. Correct?
Yes.
That's it. So it won't make a difference. It's just that you need to know by drawing the table, the normal distribution, that what you are looking for. Because the table is always fixed. The table is always for minus infinity till x, whether the x is positive or negative. Clear?
Yes.
Everyone. So now I will keep the table open and you will find some values for me from the table. We are basically trying to understand how to find the table values properly. So let me draw the normal distribution again. And please bear with me for my handwriting or for my elementary skills. Sorry. Just a moment. Okay. So as I said, you will be getting the normal distribution table given in the exam, or the values they will give you in the exam. That won't be the concern. But now I'm going to do something interesting, and this will perhaps tell us the interval. What do you mean by interval? Interval is generally a range of value. Okay. So if in the later topics, not in this topic, but in the later topics, you will be asked to find the interval or the range of something. And the range is always calculated right from the center, right from the mean. So when I want to calculate the range from the mean, for the standard normal distribution, what is the mean, guys?
0.
0. If I want to find how much is the distance of, let's say, I will say 2 divided by 3. So 0.67 from the mean. So 0.67 standard deviation from the mean. So 0.67 will be on the left and the right side both. So 0.67 and plus 0.67. How much is this? What is the probability of this? Guys, what will you do? You will go to the distribution table and you will go for 0.67. What is 0.6 and 7 here? Guys, the negative 0.67.
0.2514.
0.2514, correct? But that 0.2514 is the distance from this part. Are you getting it? Is the
Yes.
distance for this part. Do I need that? No, I don't need that. I have been given that this distance is 0.2514. I don't need that. So how do I calculate that? Very interesting. See, what is the probability for value below mean? What is the probability for value below mean? Can I say it is 0.5? 50% below mean, right?
Yes.
Out of that, you got the value as 0.2514 for the value below 0.67. So can you tell me how much is the value between 0.67 and 0? I simply need to subtract 0.5 from 0.2514. Am I correct? In that way, you will get this distance. Am I correct? Yes or no? Guys, please contribute your inputs here. Otherwise, you will find it very difficult to understand. From the distribution table, what did we get? We get a distance of 0.2514 for 0.33, for 0.33, sorry, for 0.67 we were looking, right? 0.67, we got 0.2514. That's the answer. But it is always from the extreme left, right? So from the extreme left till that, we got 0.2514. But I don't need that. I need the other value. I know the value below the mean is 0.5. Above the mean is also 0.5. So from 0.5, if I subtract 0.2514, how much is this value, guys? The remaining value?
0.248.
0.2486, right? Can I say that will be the same value for this point also?
Yes.
Because that's a normal distribution. So what is this probability? You will simply multiply 0.2486 into 2. You will get 0.497. Approximately, you will get how much, guys? This probability will be approximately how much? Can I say the probability is 50%?
Yes.
For the value between these numbers. Am I clear? Yes or no?
Yes.
What? See, approximate percentage of observation which falls within two-third. Two-third is what? 0.67, right? Two-third of the distance from the mean. So how many data is there within the two-third distance? 50% of the observation. Got it? Clear? Everyone? In the same way, if you calculate from the distribution for the distance 1, that is -1 to +1, what does it tell you? How many observations? What would be the percentage of this distance? Come on, I've written there. How many percentage of the data will be between this distance of -1 and +1?
68.
68% of the data will be between -1 and +1. Now, the more and more I become broader, the more and more data will be captured. So for 2, what have they given for 2? For 2,
95%.
how many distance is covered for 2?
25%.
I will say that they have given me around 95% of the values are covered between -2 and +2. Got it, guys? And if I say for 3, what happens for 3? Almost how much of the values are covered? If I found till 3, how much of the values are covered? 99% of the values are covered within how much distance? How much distance? 3 standard deviation away from the mean. How much of the probability, how much of the proportion is covered?
99%.
99%. Guys, can you read this? Nearly all the probabilities of a random variable are contained within 3 standard deviation from the mean. So for any normal distribution, guys, for any normal distribution, within what distance are 99% of the values covered? 3 standard deviation. Got it? Everyone?
Yes.
Do you have to remember this? Only this you have to remember, that around 99% of the values will come within 3 standard deviation. This is what you need to remember. Other, you can find it from the table also. They'll give you the table. Don't worry. But you need to remember, they ask this concept that 99% of the values are covered between what distance? You can say 3 standard deviation. Clear? Aren't you wondering at what distance is the 100% value covered? Right? Is anyone thinking like that?
Yes.
There is no answer for it. Why? 2 reasons. First, because the values are infinite.
Right.
So it will be 99 point something, but it will never be 100%. What is the second reason? Probability can never give you an answer with 100% accuracy. If it does, then it is not a random variable. Are you getting it?
Yes.
You cannot give any answer with 100% certainty for future if it's a random variable. That's why it's called, we call it as a random variable, right? Clear?
Yes.
Now this that we were calculating, this range that we were calculating, 2 standard deviation from the mean, 3 standard deviation from the mean, and so on. This range is called confidence interval. What is this called as? Confidence interval. Confidence interval is nothing but it is called as a range of values within some standard deviation from the mean. Are you getting it, everyone? So we are expecting our value to be in this range, For example, we did example 9. We were trying to find the value between 1 and 6, correct? That was our confidence interval. Everyone, clear? Everyone?
Yes.
Yes, sir.
Well, that's it about normal distribution. However, there is one small thing about normal distribution that I want to highlight here. And this is something that you should apply in your real life. In this particular example, let's say this was the stock data. This is one of your favorite stock. Let's assume that. What is the average return of this stock? Now I'm going to not use statistic. I'm going to use real life scenario. What is the average return that your stock has given in the past?
4.8%.
4.8.
4.8. Let's assume you are a US citizen. Your stock has given an average return of 4.8. You come to me and you ask me, I'm your consultant. You come to me and you ask me that, sir, I want to invest in this stock. What is its average return? I would say its average return is 4.8. Then if you ask me that, sir, what is the possibility that the stock, because it's a random variable, in future there are n number of possibilities. Tell me what is the possibility that the returns will be negative? Then generally I would say that don't worry, my friend, it won't be negative. I would give a vague statement, a subjective statement, right? But now I can give you an accurate statement that, my friend, based on the data, the possibility of negative return is 9.18%. Doesn't that sound great? That sounds more analytical, right? Everyone?
Yes, sir.
Yes.
And the client then goes and tells me that, you know what, the risk-free rate in US is right now 1.2%. Can we achieve risk-free at least? Or what is the possibility that we won't even achieve risk-free? What is the possibility that we'll fall short of achieving risk-free? How much is the possibility that we won't achieve risk-free? 15.87%, correct? Right. Now, these are the common questions of the clients. They are worried about some benchmark below which they don't want their returns to go. It can be 0% or it can be any percentage which the client has decided. They are worried about their returns going below the benchmark and they want to know the probability of it. Correct, everyone? Right? Here, when he or she was worried about the return below the risk-free, so can I say the values going below risk-free is the concern here? That means the client is worried that we'll fall short to achieve returns even equal to the risk-free. Then it doesn't make sense to invest in risky asset. Now, if your client in this case tells that I want at least 20% chance that the return, I want at least 20%, I will say rather in the other way, I want at least 80% chance that the return should be above risk-free. I want at least 80% probability that the returns are above risk-free. Will this stock be the part of portfolio?
Yes.
Will this think carefully? I said at least 80%, it should be above risk-free. Now, at least 80% above risk-free. So I can say the possibility of below risk-free should be less than 20%.
Yes.
It cannot be more than 20%, right? So here I can say the probability of less than risk-free is below 20%, correct?
Yes.
So will this be the part of the client's portfolio? Yes, because it meets his criteria. But if my client, if she tells me that, Kunal, I need 90% probability at least, you should guarantee me at least 90% that this won't fall below the risk-free, then will this be the part of his portfolio or her portfolio?
No.
No. Why? Because it is falling short. It is falling short. This concept is called shortfall risk. What is shortfall risk? Shortfall risk is the probability that your value will be below the expectations that you have. Are you with me, everyone? What is shortfall risk? It is the risk that the portfolio value will fall below some minimum acceptable level. Some minimum acceptable level is called your RL. L here is the target return. That target can be zero, that target can be risk-free, that target can be anything. Everyone, that target can be anything. So whenever I'm trying to find the probability for value below some point, if the client tells me that what is the probability that my value will be negative, that zero is the target. What is the probability that the returns will be below risk-free? That risk-free is the target. Whenever you're looking for that, that is called the shortfall risk. So just for your information, can I say shortfall risk is always the bottom value, the value below some number? You're always looking for this, the downside risk, correct? This is your RL. Why do I say RL? This is your target. You are worried that your value should not go below this, correct? This probability that you get here is called as shortfall risk. Am I clear, everyone? Yes, everyone?
Yes, sir.
So theoretically, shortfall risk, what is the problem with standard deviation? See, standard deviation tells you the risk of going up and down both, right? But as an investor, or as an analyst, you are concerned about the values below some minimum acceptable level. Correct? So theoretically, standard deviation captures variability both above and below the mean. It is said that mean variance analysis on which MPT is based considers risk symmetrical. So mean variance analysis is a concept under modern portfolio theory. MPT is modern portfolio theory. What is modern portfolio theory? It assumes that the risk is symmetrical, upside and downside both. However, in practical investment, we are more concerned with the downside risk. Are you with me on everyone? And therefore, we calculate a ratio called of shortfall risk. That ratio is called Roy's safety first ratio. Safety first ratio is nothing but the ratio which tells you what is the value of your portfolio going below the minimum ratio. So safety first ratio, the value is expected return minus the target return over the standard deviation. Here, this is nothing but very much similar like to the Z-score. Very much similar to the Z-score.
Yes,
Correct, everyone? Here, the target return, the minimum acceptable return can be any return, right? I just told you it can be zero, it can be risk-free, it can be anything, right? For example, let's say in our portfolio, our expected return was 4.8. We were worried about the value going below 1.2 divided by 3.6. So I will get 4.8 minus 1.2 divided by 3.6. I'll get an answer 1. Let's say this is for portfolio A. If I calculate for portfolio B, let's say it may have a different number. Let's say its mean is 5 and 1.2 and its standard deviation is 4. So what is the answer? 5 minus 1.2 divided by 4. Its answer is 0.95. Can you tell me which portfolio is better here? A or B? A or B? Which is giving you higher ratio? A is giving you higher ratio, right?
Yes.
So higher the safety first ratio, higher the safety first ratio, guys, higher I can say is the chance of getting that portfolio selected. Correct? So safety first ratio is going to give you safety against what? Against you achieving less than your target. Are you with me? Now we will be doing portfolio management. In portfolio management, there is a ratio called Sharpe ratio. What is the name of that ratio?
Sharp ratio.
Sharpe ratio. And the Sharpe ratio formula is exactly like safety first ratio. The only thing is that instead of RL, you have RF. It means that your target return, that your minimum acceptable return is risk free. If your minimum acceptable return is risk free, then guys, the safety first ratio and Sharpe ratio are same. I'll write here. What is the note that I'll write here, guys? I'll write a note here. If
RL equals to RF.
if yes, if the minimum acceptable return, if the minimum acceptable return, which is called RL, if that is equal to risk free, then safety first ratio is equal to Sharpe ratio. Now what is Sharpe ratio? Sharpe ratio is nothing but expected return of portfolio minus risk free rate over the standard deviation of the portfolio. So the only difference is risk free, and here it is minimum acceptable. If they both are same, then safety first and Sharpe ratio are same. Clear? And guys, higher the ratio, I can say better it is. Higher the ratio, better it is, right? And one more thing, higher the safety first ratio or Sharpe ratio, lower is the risk of shortfall. Lower is a shortfall risk. Got it, everyone? Remember this. Higher the safety first ratio, lower is the shortfall risk. What is shortfall risk? That the probability of value being less than the target, less than the minimum acceptable. Everyone with me? So I have few questions for you. Will you like to answer, everyone?
Yes.
Safety first ratio is the ratio of in the numerator you have mean minus the minimum return that you require divided by the standard deviation. Now that minimum return can be any number that the investor chooses. That is investor's risk appetite. If the investor tells me that Kunal, that minimum return should be risk free, then the safety first ratio is nothing but a Sharpe ratio. In Sharpe ratio also, you take the minimum return as risk free. Higher the ratio, better it is. So let's say if there are 5 portfolios, the one which has highest safety first or Sharpe ratio, that will be the best portfolio, then the second best and the third best. Now, the more the safety, the lesser is the risk of shortfall. So the connection is that higher safety first ratio, lower is the shortfall risk. Clear, everyone?
Yes.
Right? Now, where is this concept used? Where in real life you are worried more about the downside risk in trading, in banking sector, in every sector where there is a chance of huge loss, extreme loss. Guys, when I say extreme loss and loss, can I say negatively skewed? Negatively skewed and high kurtosis? Am I correct? In those cases, there are chances of extreme loss. Am I correct? Am I correct? In those cases, we use this shortfall risk concept. And this concept is generally used in the banking sector and various other sectors. So the concept of shortfall risk, along with the normal distribution that we did, we calculated the probability, plays an important role in financial management, especially later on in level 2 and all. You will see some concepts like value at risk, VAR, stress testing, scenario analysis. These are different ways of calculating risk. And at that time, we will use the shortfall risk and normal distribution concept. So in future, in level 2 or in the banking sector or finance sector, if you're working, you will have to constantly calculate what is VAR, stress testing and scenario testing. These are some things which are done, which are asked compulsory by the regulators. In those cases, guys, in those cases, you will use this concept of shortfall risk and normal distribution. Not now in level 1, neither in your real life now, but later on, if you're in the banking sector or if you're in trading investments, then there is a requirement where you have to constantly calculate what is the extreme risk possible and what is the probability. In those cases, we exclusively use the safety first ratio. Okay. For example, let's say your Jay is into trading and Jay is the portfolio manager and he has a team of 20 traders working for him. So he will have a mandate that our portfolio should not be below, let's say 5% in a day. Okay, let's assume that in a day or in a year. So that 5% is his minimum acceptable return, right?
Yes.
Correct. And he will constantly keep on checking what is the probability of this returns going below 5%. Okay. So he will calculate the safety first ratio of all the traders in his team. And the one who has highest possibility, right, of getting it, the more shortfall risk, that trader will have to be taken care. So he will take the overall portfolio returns of all the traders and then see whether his overall portfolio is meeting the minimum acceptable return. If not, what is the shortfall risk? Let's say he's decided that the shortfall risk should not be more than 5% or 10%. So at any time the probability exceeds more than 10%, he will tell probably to stop everyone to do the trading, because then the risk of his portfolio has increased. So he will call all his traders and tell, square off your position, close down your position, because the risk of the companies exceeded the minimum acceptable level. Got it?
Yes.
In this way, we apply it in real life. Of course, in today's era, everything is managed by the computer and technology. You don't have to manually do it. So in most of the trading departments now, what happens, guys, that there is an automatic, a pop-up or a signal or an announcement, or on your screen itself, it shows that the the portfolio of the organization is exceeding below its acceptable level. The risk, the shortfall risk is exceeding below the level, and then all the trading suddenly stops and the position gets auto squared off. So this is the new risk management system in most of the high level organizations. Correct, everyone? So remember the concept of shortfall risk and the safety first ratio, which is very much similar to Sharpe ratio, and Sharpe ratio we'll go in more detail when we do portfolio management. Okay. So what are the types of distribution you've done now? Continuous, uniform, and normal distribution, right? Everyone?
Yes.
Now, normal distribution has equal possibilities of value below 0 and above 0. Am I correct?
Yes. 0.
Below 0 and above 0. Am I correct? So the possibilities of value below the mean and above the mean, let's say standard normal 0, is equal.
Yes. 50%.
Now, guys, tell me one thing. When I'm calculating stocks returns, is there a possibility of positive and negative return? Yes, there is a possibility that the returns will be positive. There is a possibility that returns can be negative, right?
Yes.
Everyone. So when you're calculating stock returns, the possibility of positive or negative return is there. But guys, when you're calculating the possibility, or when you're trying to do the distribution, not for returns, but for the prices of the stock, can the prices go below 0 and above 0 both? Can the prices of asset go below and above 0? Can the price of any asset go below 0? Especially if it's not derivative. Can the prices of stock go below 0, everyone?
No.
Yes or no?
No.
It cannot go, right? It is bounded by 0. The minimum it can go is 0. So can I say the downside is limited and the upside is unlimited? Well, if that's the case, then this is not a normal distribution. Why? Because it is skewed. It is skewed on the right, isn't it?
Yes.
Yes.
This type of distribution is called log normal distribution. Why? Because there are some problems with normal distribution. It assumes that Normal distribution has no lower bound. It assumes infinite on the lower and upper side, right? However, in practical life, asset prices cannot go below zero. They cannot go below zero. Asset prices cannot be negative. Their returns can be negative, but their prices cannot be negative. Therefore, whenever you are trying to find asset returns, you can use normal distribution. But whenever you are modeling for asset values or asset prices, you cannot use normal distribution. Everyone with me? And therefore, we use log normal distribution. Log normal distribution accurately takes into consideration. It is very useful for accurate description of asset prices. So whenever you're trying to find the price or value, for example, let's say you're trying to find the project's NPV, net present value. So NPV going below zero is possible, NPV going above zero is possible. But if you're trying to find the value of your property, what is the probability of, what is the possibility of your, property value being something? In that case, you cannot use normal distribution because it assumes the value will go below zero. And we know the value cannot go below zero for the property value. Therefore, whenever you see value, you have to use log normal distribution. Whenever you say returns, which is in percentage, you can use normal distribution. Correct, everyone?
Yes.
So log normal distribution is closely related to normal distribution. It is closely related, but not normally. Why? Why it is related? Because again, here we are going to focus on mean and variance, the two parameters. But the two important difference between normal and log normal, it is that it is bounded by zero and it is skewed to the right. Clear, everyone? See, it is bounded by zero and skewed on the right. Am I correct? Yes, everyone?
Yes.
Now, in your calculator, you already have a log natural function. Have you seen that? Where is it? Can you recollect where is that function, log normal? Do you see ln somewhere? Where do you see ln? No? See here, just below 7, just beside 7. Do you see that? ln, everyone?
Yes.
Now, that ln is log natural. And what is behind that ln? E raised to x. Do you recollect something doing like e raised to x in time value?
Yes.
Where? Tell me where. Do you recollect that somewhere?
We're infinite. We are finding infinite.
That is continuous, isn't it?
Yes.
Whenever you're doing continuous, and aren't we into continuous distribution? Right? So e raised to x is exponential, right? Continuous compounding.
Yes.
So what is log natural? Log natural is continuous discounting. I'll repeat. If e raised to x is continuously compounding, log natural is continuously discounting. Now you must be wondering, what is he talking? Okay. Now let me show you. Can you calculate for me the exponential of effective rate? You know how to calculate the effective rate, guys?
Yes.
You know how to do that, right?
Yes.
So I will give you a number and you have to calculate the effective for it. Okay. Second icon V function. You are aware, right? So press second icon V. Everyone press second icon V. What is that on your screen? No one? Is your
Nominal.
screen blank? Nominal, right? So in the
Yes.
nominal, you are going to put 9.53. I want you all to put 9.53. And in the compounding frequency, put 999. What is the effective answer?
9.99.
9.99, approximately 10, right?
Yes.
Correct. Now, if you want to try the same thing in another way, now what did you do, guys? You did, see, listen this very carefully. You have done the exponential of 9.53, which gave you 10%, right? If you do the log of 10, you will come back to 9.53 because log does the opposite of exponential. Got my point?
Yes.
I will show you how. Log is the opposite of exponential. Log is the opposite of exponential. So here you have a function e raised to x, everyone. Now we are going to use that function e raised to x. What is the return I gave you? 0.0953, right? 0.0953. So in your calculator, guys, press 0.0953. 0.0953. Everyone with me, please do that. And now press second ln. Press second ln. When you press second ln, it is actually exponential. When you do that in your calculator, you get 1.1. Am I correct?
Yes.
Now, when you do -1 from 8, it is nothing but 10%. Clear? So 1.1 is 10%. Everyone, it's in factor. Am I clear?
Yes.
Now, 1.1, that is 10%, is the effective answer, right? Now, if you want to go from effective to nominal, what do? Just press ln. Press ln. Just press ln. You'll come back to 0.0953. Got it, everyone? Yes or no? I'll repeat. When you press 0.0953, when you pressed 0.0953, and then you press second ln, which is nothing but e raised to x, you got an answer of 1.1, which is nothing but 10%, right? It's in factor. And then when you did the log natural of 1.1, you got an answer of 0.0953, which is nothing but 9.53%. Are you getting it, everyone? So what has happened here? What has happened here? Come on. If you use e raised to x, exponential, it gives you the value. It gives you an effective rate. But if you want to convert the effective rate into the normal rate, which is the stated rate, what will you use? No answers.
ln function.
You will use the function of log natural. So guys, if there is x, if x is, let's say if x is a nominal rate, right? E raised to x is the effective rate. And if I use log natural of e raised to x, I will again get back the x. So here, when I use 9.53, e raised to 9.53, I got an answer of as 10%, isn't it?
Yes.
Which is I got an answer of 0.1, 1.1, correct?
Yes.
And if I use the log natural of this, I will again get back to 9.53%. Am I correct? This is the same concept that you must have done in your childhood, that log natural of e raised to x is nothing but x. Log of e to the x is nothing but x. Have you heard about this concept long back?
Yes.
This was the day that you were waiting to understand its meaning. Are you with me? Log of e raised to x is nothing but x. Now, can I tell you something? Log and something that we have learned in our school and colleges is anti-log, right? Log and anti-log, right?
Yes.
That anti-log is nothing but exponential. Are you getting it? Anti-log is nothing but exponential. Exponential is continuous compounding. Got my point? Everyone? So from nominal rate to continuous compounding, you use e raised to x. Correct, correct, correct. But from continuous compounding, that is effective rate, to back to nominal rate, you can use log natural. Everyone with me on this point?
Yes.
Everyone, right? See, this is an interesting part that we are going to use, and we are going to now use for an example of log natural. I'll tell you what it is. Now, first, here there is a formula of returns, and then you have to take the mean and variance of the returns. But again, the returns here that will be given to you are continuously compounding. So how will you convert the continuous compounding returns into the normal returns? How will you do that?
Log function.
By applying log natural, correct? So take this example 10, everyone. What is this example 10? For a given daily prices of stock below, calculate the annual volatility. Annual volatility, everyone. Annual volatility for the stock assuming 250 days in a year. So there are 250 days in a year, and these are daily prices. These are daily prices. Now guys, the daily prices, so day 1, day 2, day 3, day 4, 5 and 6. Now the returns that you are going to get from this, they are actually continuous compounding returns. They are compounded every time. So ideally, if I want to calculate x1, what is x1? Return of first day. So ideally, how do I calculate return? Ending minus beginning, correct?
Yes.
So normally we do 79.2 minus 78.9 divided by 78.9, right? What is the return that you get? Can you tell me? 71 day return between these two values, 79.2 minus. So you can write it here as, see this, you can write it here as 79.2 minus 78.9 divided by 78.9, correct? What is the answer? Can you tell me?
0.3.
I'm not getting anyone's voice.
0.38.
Can you be a bit loud, Jay?
0.38.
0.38 percentage, right?
Yes.
Now hold on. The same thing you can also find in another way. I will show you another way. That is nothing but just take the ending value, that is 79.2, and divide it by the beginning value 78.9 in your calculator. Just do that. 79.2 divided by 78.9. Your answer will be in factor 1 point something, right? Now again, if you will subtract minus 1 into 100, you will get your answer 0.38 percentage, correct? Everyone? Yes or no?
Yes.
Now, these are continuous compounding returns and I need to normalize them. So what will I do? To normalize them, I will have to apply the log natural. The log natural of the return. What is my return? 79.2 divided by 78.9. Can you calculate this, guys, now? You'll get something like this, 0.0000379. I will cut it short to 0.0038. How will you calculate? In your calculator, 79.2 divided by 78.9. Whatever answer you get, just press ln. Got it, everyone?
Yes.
Store this value. Put this in store 1. Store it. Now, how do you calculate second day return? Can you tell me, how do I calculate second day return? 78.7 divided by 79.2. Everyone, calculate that in your calculator and press ln. Your answer will be 0.004 decimal. I'll take 0.0063 negative. Are you getting it?
Yes.
Store that, store 2. The same way, let's calculate the third one. Log natural. 77.9 divided by 78.7, and you'll get a value of minus 0.00102. Everyone, store 3. Let's do the fourth one. Log natural. Remember, these are exponential, so you need to convert them into normal, and that's why we are doing log natural. 78.4 divided by 77.9. Your value is 0.00639. I will do 0.00634 and store 4. 78.4 divided by 77.9, 0.00639, or you can just keep 0.00, correct? 639, I will keep 0.00639. Okay, you can keep it this, or you can just keep it 0.64. Are you getting this value, guys?
Yes.
Store 4. Now, next year return 5. Next day return, sorry, not next year, is a daily return. What will I put here, guys? 79.1 divided by 78.4, and I will get the answer 0.00888. I will take it 0.00888. Recurring it is, I will take 9. Store 5. Everyone. Okay. Now, what do we have to do? We have to calculate its mean and standard deviation. Now, in order to calculate mean and standard deviation of any data, you need to press second 7. And then you need to press second stat, isn't it? Correct, everyone? So, how will you get mean? Guys, press second 7. Second 7. What do you have on your screen?
X01.
What will you put X01? Press recall 1. Recall 1 and enter. You have already stored the value, right? Press recall 1 and enter. That will be your X01. Got it? Now, leave Y01 as it is. Leave Y01. Keep it 1. Because you have only one variable. What will be your X2? Press recall 2 and enter. Don't forget to press enter. Got it? In that way, keep on doing till X5 and then press second 8. Keep on doing it, guys. You will go for X03, recall 3, enter. Then X04, recall 4, enter. X05, recall 5, enter. And then press second stat or second 8 as what we call. Let me know what is your mean.
Zero 0.0005.
0.0005.
Yes.
And what is the standard deviation? Go down arrow and just let me know S. What is the standard deviation?
0.0083.
83. That is the standard deviation. Correct, everyone? Is everyone getting this answer? Very good.
Yes, sir.
But this is daily standard deviation. This is daily standard deviation. Guys, tell me one thing. If your 1 day variance, if your daily variance, okay, not standard deviation. Let's say if your variance of 1 day is something, you get something as a variance. Let's say the variance I take is 100. How will you convert this into standard deviation? Or first of all, let's say from variance of 1 day. 1 day variance is 100. So how will you convert this into 250-day variance? If I want to convert this into 250-day variance, what will I do, guys? I will simply multiply it by 250, because if the 1-day variance is 100, for 250 days it will be multiplied by 250, right? And if I want to calculate standard deviation, what will I do? I'll do the square root of all of these, right? Clear, everyone?
Yes.
So when you want to convert a daily variance into any other variance, it can be yearly or monthly. What you do, you simply multiply the variance with the time, correct? But when you want to do that with the standard deviation, should I multiply with time? No. What is standard deviation? It is square root of variance, right?
Yes.
So when you want to directly do with standard deviation, you have to do square root of t. You have to multiply it with square root of t. Are you getting me? Did you note the change? No. Let me explain again. Because when no one answers, I think people are confused. Okay. What is variance? 1-day variance is, let's say, x. If I want to make it into some time, I will multiply with time, right? So I will do this. Let's say variance is this, and I multiply with time. So I may get a variance for yearly or something like that, from a daily to a yearly. If I want to do that with standard deviation, how will I do that, guys? I will do the square root of it. And what will this become? This will become square root of variance is nothing but standard deviation multiplied with square root of t, isn't it? Yes or no?
Yes.
So what I got is a daily standard deviation. What they had asked is annual volatility. You see this annual. And how many days in a year they have said? 250.
250.
250 are basically the trading days, okay? So if I want to now convert standard deviation from daily to annual, what will I do? Guys, I will multiply it with 250 or square root of 250.
Square root of 2.
Square root of 250.
Why? Because it's standard deviation, right? So my answer will be 0.0083 multiplied with square root of 250. That will be my answer. Got it, everyone? Let me know what is your answer. First, what are you going to do, guys? First, you're going to do square root of 250 and then multiply it with what answer you got. Clear? Your answer is 250 square root and then multiply with 0.0083. Your answer is 0.1312. Am I clear? Guys, just see above. How did you calculate mean? You just took the returns of all. The log natural returns. Why the log natural? Because you had continuous compounding returns. So you converted them into log the normal returns. Then you added all this to calculate the mean, right? Well, in order to get the variance, variance is variance into t. You convert the variance, right? But when it is standard deviation, you take the square root of t, because variance square root becomes standard deviation, but t also you have to do the square root. Everyone clear? So if I've converted the variance into t, the standard deviation will be standard deviation into square root of t. So what is the process we did under log normal distribution, guys? This is generally for asset prices. See here, there were prices given, not the returns. There were prices given, not the returns. And from the prices, which is log normal, I want to calculate the returns. So the daily returns I calculated, and since they are prices, they are log normal distribution, right? So you did the log natural of all the returns, then you calculated its mean and standard deviation. How did I do? First, I make you calculate all this and then store it. Then you press second data and put all this value as recall 1. That makes the job easier. And then you calculate the mean and standard deviation. They had not asked us the mean, they had asked us the annual volatility. Volatility means standard deviation. So in order to get annual standard deviation, I wanted the standard deviation, but here the prices are daily. So I get the daily standard deviation. And then in order to convert into annual, I multiply it with the square root of t. Why? Because standard deviation is in square root terms. Had they asked me annual variance, then I would just multiply with 250. But they have asked me annual volatility. Volatility means standard deviation. Therefore, I multiply with annual. I multiply with the square root of 250. Clear? Everyone?
Yes, sir.
Yes.
Now, I know y'all are already exhausted, but just see the index. We are done with all the types of distribution, correct? Now, only there is a last distribution which we need to do the discussion is the Monte Carlo distribution. Monte Carlo distribution, guys, you don't have to do calculation because calculation is not possible. Everyone. So the last distribution that we are going to do is Monte Carlo simulation, or Monte Carlo, you can say distribution. What is Monte Carlo simulation? First of all, what is simulation? What is simulation? Simulation. Have you heard this word simulation? No? Okay, let me show you something. Let me quickly, I'll show you that. Have you heard about simulation in real life anywhere? Don't tell me you haven't heard about simulation.
And games and weapons and all this stuff.
Where? In?
Like, oh, इसमें था ना sir game में simulator like a first copy of
Games.
a flight
Correct.
first
In
copy of
games.
a machine
Okay.
gun and all.
Okay. Fine. Let me draw this. So if you have just some idea about a project, a simple project, okay? So tell me in projects NPV, if you calculate the project's NPV, let me first share the screen. Okay. Now, in order to get the project's, NPV or net present value, you evaluate the project. So what all things you do? You take a financial statement, you predict the sales, right? You predict the cost. You have a lot of prediction. Then you also, one of the costs that you may predict is the cost of the raw material. You may also calculate the depreciation. You may also predict what will be the interest expense. You may also predict what is the tax. And there will be so many expenses between that. Let's say admin expense and so on. And then finally you will get net profit. And based on that, you may probably get multiple years net profit, and you can estimate net profit for the future years. Now, what if I assume that, let's say the sale is 100, the raw material is 2, the depreciation is 1, the interest is 5, admin is 1, something like this. Raw material I'll take 40, tax is 10 and something, and I will get my net profit. But guys, here, what if I change one of the factor, keeping all other constant? Can I tell my net profits will also change? Can I say that? If I just change one factor, everyone, then will my net profit be the same? Let's say if I increase the raw material by 10%, my net profit will also change, isn't it?
Yes.
So any factor you change, keeping all other constant, you change one factor, keeping all other constant, then your net profit will also change. This process is called sensitivity analysis. What is it called as? Sensitivity. Why? Because I'm changing one factor, keeping all other constant. Got it? But what if I change simultaneously multiple factors? For example, I change the raw material, I change the depreciation, I change the interest, and I change multiple factors together. Then that's called a scenario analysis. So what is sensitivity analysis? Guys, what is sensitivity analysis?
Changing a single factor.
Changing a single factor. And when I change multiple factors, I get a scenario analysis, right? So let's say one of the scenario is worst case scenario. Then you have the best case scenario. Then so on, you can have multiple scenarios. Now just imagine you putting 10,000 different scenarios, different combinations, 10,000 different combinations on the spreadsheet. Why on the spreadsheet? Because manually doing that is impossible, right? Correct. So can I say all the different scenarios? Let's say you take 10,000 combinations. So all the combinations will have different profits.
Yes.
And then if we take the mean and standard deviation of all those profits, that process which the computer does is called as simulation. Everyone got my point? What is simulation? Now let's read what is written and then it will make sense. Simulation or Monte Carlo simulation is a computer-based technique used in finance to represent complex scenarios. It considers thousands of different scenarios and gives a probability distribution, which we saw in normal distribution, probability distribution based on large number of random variables. Who does this? Well, we cannot manually do it. So computer is used to generate random values based on different parameters. So the parameters we said is raw material, labor cost, depreciation, interest, and so on. And you take all the risk factors that you think are essential. Based on that, all these risk factors you take. For example, when I'm evaluating an asset's price or asset's value, I may take the interest rate, the time factor, the growth rate, the dividend and cash flow, and so on. I may take all the factors, and based on that, I may run a computer generated simulation. This is called Monte Carlo simulation. This is computer based. This is not part of your syllabus. You don't have to manually do it, but this is how in real life multiple scenarios are predicted. And then from all those scenarios, what we do, we take a mean and standard deviation of it, and then we plot in the normal distribution. Got my point? Why is it called Monte Carlo? Monte Carlo is actually a place somewhere in Europe, I think. And Jay, you just mentioned me that simulation is a word that you've heard in gaming, right?
Yes.
And this simulation actually comes from, I think, as far as I'm concerned, this technique of Monte. Why is it named Monte Carlo? As far as I remember, it comes from a gambling industry. So Monte Carlo was a place for gambling, and from there it comes. So this is the connection that you say. Basically, you've heard it in gaming is because of this. That also means that you're gambling, right? Are you playing poker or anything? Don't tell me no. You are right.
Sometimes.
Sometimes. So that's where this helps. This is helping you in finance. So it actually comes from the gambling industry, this word, and that's why it's called Monte Carlo simulation. Got it? See, this is the way I am an analyst. I caught you. So basically, Monte Carlo simulation is, and that's the reason why only Jay could give us an answer, because this is exclusively used in the gaming industry. That's why it's called Monte Carlo. Name comes from that. Now, where is this used? This is used in modern gambling. And what is modern gambling? Trading. So for example, in option strategies and in modern day business where there is high risk involved, high risk is involved in trading, complex trading, or, calculating value of portfolio when the distribution is non-normal. Non-normal is skewed, extremely risky. Or as I said, is value at risk. Value at risk is VAR, which we will learn in level 2 and so on. In such complex scenarios, you need to see not one or two choices, but you need to see multiple scenarios which are possible. And in that case, we use Monte Carlo simulation, correct? Why? Because we can use tens of thousands of scenarios. Is it possible to do manually? No. Therefore, we use Monte Carlo simulation. So that is the use of it. However, there are some demerits that this model is very complex. And since it is just based on numbers, we say this is based on various assumptions and they are simply assumptions. So the answer is no better than the assumption. The more vague your assumptions are, the more vague your answers will be. Correct? And some people say that it has only a statistical scope. It is less analytical. It has no economic relevance or it has no practical significance. It is just a statistical number. That is one of the demerits that people say. However, I still believe that Monte Carlo simulation is one of the best techniques that the computer has helped. And this is the next step of this Monte Carlo simulation is nothing but this is where algorithms were originated. algorithm, guys, you heard about this, right? All the algo trading today that you see is actually because of the boon of Monte Carlo simulation. Algorithm, by the way, was introduced in World War II by Professor Alan Turing, on whose name we have algorithm. He is the first who used this simulation to crack the codes of the Nazi army, or the Nazi, the naval and the air forces and so on. He used those codes by his computer technique, and that's the technique that we use today in the financial world also. And that is what Monte Carlo simulation is. Unfortunately, he had to do suicide and all that, and that's a different story. If you want to know more about it, there is a movie of Benedict Cumberbatch on algorithm or Alan Turing, and that movie is called The Imitation Game, I think.
Yes.
Yes, sir.
Imitation.
You've seen that
Yes,
movie?
I've seen that. Yes.
That is the movie based on Alan Turing and on his real
Yes.
life. And he's said to be the father of algorithm. And in algorithm, if you see in the movie, he's using a different
Oh,
combination
yes.
by putting
Combination.
that number, right?
Yes.
That is
To
simulation.
increase the messages.
That is simulation. And today we use the same simulation with the help of computer. And that is nothing but algorithm trading. His contribution to the world of algorithm is remarkable. Unfortunately, he had to die with suicide because the government had charged him for homophobic violation of homophobic laws. But I think in 1998, the Prime Minister of Britain, the then Prime Minister of Britain, Tony Blair, I think he publicly apologized for the crimes of the previous government, and then he was rewarded posthumously because he had committed suicide. So he was rewarded posthumously. So that is what. So his concept of algorithm now used with computer is Monte Carlo simulation, right? Now, before him, people were relying on the manual way, that is, on the historical data. So you have historical simulation and you have Monte Carlo simulation. Historical simulation, guys, can only take those data which had actually occurred in the past, right?
Yes.
It's historical data. But Monte Carlo simulation will also take those things which have not happened. So the advantage of Monte Carlo simulation, it is based on assumption. And this is where I can say historical simulation will only reflect those risks which have occurred. That's a disadvantage. But Monte Carlo simulation can also take imaginary situations. Everyone, it can also take imaginary situations like the COVID. Historical simulation won't take COVID, right? Monte Carlo simulation may have predicted COVID or war or nuclear war, whatever fantasy you want to imagine. All that you can take into Monte Carlo simulation, correct? So if the CFA Institute asks you what is the which type of simulation takes futuristic or unrealistic scenarios, Monte Carlo or historical?
Monte Carlo.
Monte Carlo, because it can take any possibilities that you desire. Clear, everyone? Now, of course, you don't have to calculate Monte Carlo simulation because that's a computer-based technique, but the process is same. You just calculate the mean and standard deviation with the help of computer by taking 10,000 of scenarios and then plot them into normal distribution and then find whatever question you want to perhaps answer. Just imagine that you had calculated the mean and standard deviation using Monte Carlo, and then you went and then that mean and standard deviation was 4.8 and 3.6, correct? And then you do the normal distribution to find the answers. This is how people use it in real life. Got my point, everyone? Clear?
Yes, sir.
Yes.
Well, this is the end of one of the most interesting topics of quants, that is common probability distribution. Everyone, trust me, I don't expect you all to understand it in one go. Definitely, you'll do the revision and you'll understand. But it is very interesting and very logical. If you have any doubts, let me know. This is the end of our common probability distribution. Now we are left with sampling and hypothesis that we'll be covering in the next topic. And hopefully we'll be done with quants by the next few sessions. Okay. So, guys, if anyone has any doubts, please let me know, or else we'll meet in the next session. Correct? Anyone has any doubts?
रिवीजन के टाइम पे आएंगे सर.
No, thanks.
So far, no
No,
doubts.
So, okay. So if there is no doubt, let me do some announcement. Guys, we are done with reading 6 and we are also done with the test of that. Now we are done with reading 7, 8 and even 9. Okay. So of course for reading 9, I know that you will require time, but we are due with the test for reading 7 and reading 8. So I am going to open the test today for reading 7 and 8 tomorrow. Today you all enjoy the weekend. So tomorrow I'll open the test for reading 7 and 8 and you have time till the next Saturday we meet. Before that, on Friday, I will close the test. I had kept the test open and people did not respond to me and the test was open because only when I close the test, everyone will be able to see their marks and get the solution. So from Monday till Friday, you have time. You just have to spend half an hour twice, 20 questions, right? Of reading 7 and 8, because otherwise you won't revise. So Monday, I'll open the test. You are going to give for reading 7 and 8 simultaneously. On Friday, I'll close the test. Whosoever have given the test, they'll get their marks and solution. Otherwise, you miss the test. So when we meet on the next session, we are focusing on reading number 10 and 11, that is sampling and hypothesis. And then when both the tests are done, in the next session, then after that, I'll open the test for reading number 9 and so on. Correct? So we need to catch up with the test also. So those who have not given the test, do give the test. I'll repeat what I had repeated in the last session, that how much marks you get is not important for me or for you either. Your approach, your attitude, your effort is important. So you giving the test is more important than your scores. So whether you get 50% or you get 100%, that is not important for me or for you right now. You get good percentage, it's good. You get bad percentage, don't worry. You giving the test is more important. Okay, so please give the tests. Right, that's it from my end. If there are any queries, let me know. Otherwise, we meet in the next session. Thank you. So if there is any doubt, let me know. Otherwise, we meet in the next session. Goodbye. Take care.
Bye. Take care.
Thank you.
Bye.